Well, hello again, everyone. Mr. Reeves back with you yet one more time, where today we are continuing to look at exponents. So, we spent a little time looking at what an exponent is, looking at exponents' powers, where we had rather a positive base, where we had a negative base, where we had a base that was a fraction and maybe a base as a decimal. So we kind of have an idea or a good idea, hopefully, now of what exponents are and how they work. So we're going to continue today, and we're going to be looking today at integer multiplication, or better yet, to say rather, multiplication of powers. I was reading up here where it said integer multiplication and it threw me off. We've been studying integer multiplication, but we're moving on from that. Now we are looking at powers and exponents and bases. So I'm going to go ahead and pull away from the textbook because it's really not that helpful right now for what we're looking at. And we're just going to dive in here and we're talking about multiplication of powers. All right, so multiplication. Sorry, it takes me a little while to write this out. Always takes longer to write things than to say things, right? Multiplication, no S, Mr. Reeves, of powers. Multiplication of powers. All right, so let's talk real quick about a power. So let me write this down here. I'm going to write a b to the x here, okay? This entire thing is called a power. Got it? This entire thing is called a power. Alrighty, I'm going to switch colors up here so we have a little more distinction between these. This b is called the base. All right, that is the base. This is called the exponent. And this over here in front is called the coefficient. Okay, so we have a base that is being repeatedly multiplied by itself. The exponent tells us how many times this multiplication is occurring. And this coefficient is out front to tell us how many of those we have. By the way, sometimes this exponent is referred to as a power, which is really confusing because the whole thing is a power, and also the exponent is also often called a power, right? So if I were to write that like that, we often say that is 2 to the third power, right? 2 is the base and 3 is the exponent, right? But we say 2 to the third power. So when someone says power, you kind of have to listen for the context. Are they talking about the whole expression, or are they talking just about the exponent? All right. So let's take a look at some problems here. So let's, first of all, if I just asked you, what is 7 times 7 times 7 times 7 times 7? Well, you might get out your calculator, right? And you might put in 7 times 7 times 7 times 7. But if I ask you to rewrite 7 times 7 times 7 times 7 times 7 as a power, what would it be? It would be, well, the base is 7, right? The base is 7. It's being multiplied. 1, 2, 3, 4. There are 5 sevens. So it is 7 to the 5th power, right? 7 to the 5th power. Again, the base is 7. The exponent is 5. By the way, the ones we're doing now don't have coefficients. I wanted to throw that in there. So if you're going, well, wait, where's the coefficient? It'll come later, all right? No worries. We'll have coefficients later. So what if I wanted to rewrite as a power? All right, what if I said negative 2 times negative 2 times negative 2? All right, you'll notice I have the parentheses here. That would be negative 2 to the third power. Now again, I am simply rewriting these as a power. I'm not asking you to evaluate them. If I was going to ask you to evaluate them, maybe you'd get out a calculator for this one. Certainly this one you should know would be -8, right? So these are exponents, all right? We are writing them as powers. But what if I give you a multiplication problem, right? What if I asked you to multiply? What if I asked you to multiply that 7 to the 5th that you had right there times a 7 to the 3rd? What would that answer be? All right. Now let me tell you what many times my students will say. I say, what is 7 to the 5th times 7 to the 3rd? And let me tell you one of the most common answers I get. 49 to the 15th power. 49 to the 15th power. All right, now I meant to do this before, so bear with me a second. I'm going to go ahead and pull up my TI calculator here to help me out a little bit because it's kind of important for us to take a look at the values of these. Okay, so we have our calculator here. You can go away, Mr. SmartView. You're blocking my screen. Can you please? Thank you for getting out of the way. All right, so let me just check my answer in the calculator. All right, so I'm going to put in 7 to the 5th power. By the way, that caret right there, when you see that, that means to the 5th power. Okay, and then I'm going to put times, and then I'm going to do 7 to the 3rd power. So do you see how I have 7 to the 5th power times 7 to the 3rd power? And my calculator tells me, whoa, it is, let's see here, 5,764,801. Woo! All right, so now let me put in 49, 49, there we go, 49 to the 15th power. What do you think? Am I going to get 5,764,801? Let's see here. Whoa, what is this? 2.2539403 times 10 to the 25th power? All right, you know what? That's scientific notation, which is where we're going with all this power stuff and exponent stuff eventually. But guys, do you agree those are not the same? If you know anything about scientific notation, you would know that this number is much, much, much bigger than that number. They are not equal. They're not the same. Okay, so great, Mr. Reeves. You told us that it's not equal. Thank you. What a guy. Okay, but what does it equal then? All right, well, let's go back to the meaning of these powers, okay? We had a base of 7 to the 5th power. That's 7 times 7 times 7 times 7 times 7, right? Do you agree with that? 7 to the 5th power. And then this dot multiplication here, you know what? I'm going to put it right there, and I'm going to make it bigger. But you know what? It's the same as those dots. It's all multiplication times 7 times 7 times 7. So what do I end up with? Are they 49s? No, they're not 49s. They're 7s. And how many do I have? 1, 2, 3, 4, 5, 6, 7, 8. No way. 7 to the 5th times 7 to the 3rd is not 49 to the 15th. It's not even 7 to the 15th, all right? If maybe you were thinking that, okay. It's not even 7 to the 15th. It's 7 to the 8th. In fact, if we go back to our handy-dandy calculator, right? Once again, it's gone because I cleared it out, but I'm going to do it again. 7 to the 3rd times, which I did in the wrong order, but it's a good thing multiplication is commutative. We can multiply in whatever order we want to. So 7 to the 5th times 7 to the 3rd. Does that number look familiar? Okay. Now I'm going to do 7 to the 8th power. And take a look. It's the same. Woohoo! Woohoo! By the way, that does not prove, that proves that these two are equal. It doesn't prove anything in the general case. All right, but we're going to be taking a look at here at the general case. So if we say, okay, how do I get from here to here, now that we're pretty convinced this is the right answer, we'll take a look. The bases stay the same because what are they? They're all 7s, right? And then what did we do with these guys? Did we multiply them? No, we added them, right? We added them. So if I were to do another problem, say I had, let's do this, negative 2 to the 3rd power. Let's say I wanted to do that times negative 2 to the 8th power. Why did I pick 8? All right, probably because I saw an 8 there. Well, again, if we look at the meaning of what this one is going to be, it's going to be negative 2 times negative 2 times negative 2 times, oh my goodness, negative 2 times negative 2 times negative 2 times negative 2. Did you really pick 8, Mr. Reeves? Times negative 2 times negative 2 times negative 2 times negative 2. 8 of them, right? How many did I have here? I had 3. How many did I have here? I had 8. The base is still negative 2. By the way, I could have put parentheses around all these, but I didn't to save time. And how many do I have? 3 plus 8, which is 11, right? So if we were to do our color coding thing, because Mr. Reeves loves color, right? This time our bases were all negative 2s, right? Our bases were negative 2s. All right, what did we have? We had 3 of them. We multiplied by 8 more of them, and when we were done, we didn't have 24 of them. We had 11 of them. And just to prove that I am correct, let's clear this out, right? So what do we have? By the way, the base is negative, so I'm going to put it in parentheses. We had negative 2 to the 3rd power times negative 2 to the 8th power, right? And when we do that, we get negative 2048. What did we say the answer was? We said it was negative 2 to the 11th power, which, drum roll please, is also negative 2048. All right, so let's go back to where we were. There we are. All right, and let's see if we can generalize this case. Okay, so what I'm going to do in generalizing the case, I'm going to move away from bases with numbers and use variables. All right, so this is going to be our product rule. Okay, we're going to call this our product rule. Remember, product is the answer to a multiplication problem. Okay, so I'm going to say a to the m power times a to the n power. Notice the bases are the same. That's going to be a to the what? What did we do with those? We added them, right? M plus n. Or if we do our color coding, right? Our bases, right, were a's. And then what did we do with these? We didn't multiply them. We added them, right? So I don't really have to know what the base is. I just have to know that the bases are the same, right? The bases have to be the same. So let's do some examples, shall we? So if I asked you x to the 4th times x to the 7th times x to the 2nd, all right, the bases are all the same, right? They're all x's. So what am I going to get as my base? I'm going to get an x, right? And what did we say we're going to do with these powers? What are we going to do, ladies and gentlemen, boys and girls? We're going to add them. It's going to be 4 plus 7 plus 2. But unlike up here where we didn't know what m and n are, we know that 4 plus 7 is 11 plus 2 is 13, right? Now, of course, I can't put this one in my calculator and check it because that base could be anything, right? So of course, I could pick something for the base and put it in, and then that would show that it's Correct. So this right here is our product rule, okay? This is what you are going to be using to solve multiplication problems. The base stays the same and you add the exponents, right? So if I were to write this out, keep the base the same, okay? And then what are we going to do? We're going to add the exponents. And guys, this product rule applies whether your base is a number or whether your base is a variable. All right? All right, in another video, we will come back later and we'll throw some coefficients on and see how perhaps things look a little bit differently when we have coefficients. But we're not there for today. All right, I'm going to go ahead and end this video. And in my next video, I will be doing some more examples of the product rule. All right, I hope you have a great day. See you next time. Bye.